My name is Adam Ierymenko. I'm the original author and the founder of ZeroTier Inc. And I'm here to start off today by telling you all what ZeroTier is and what it does. So the tagline I used here is one that we use sometimes describing at a high level what this is. I call it the Planetary data center. And then everyone asks, what is that? Like, okay, what does that mean? Sounds kind of hand wavy, got the crackpot in here. So I'm going to explain what that is, how it works, and what you can do with it. So the key here is to be able to manage everything everywhere in the same way. The Planetary data center means that what we're kind of trying to do is, in a way, kind of kill the cloud, but not by getting rid of the data centers and stuff, but by eliminating the distinction. So, cloud is AWS, cloud is your phone, cloud is your laptop. It doesn't matter if it's on Earth and connected to the internet, it's in the same data center. So what ZeroTier gives you is it gives you a what we like to call a planetary smart switch. So imagine that everything's in the same building, the Earth-Moon system, and you can create VLANs, you can assign things to those VLANs, you can authenticate them, you can set network flow rules. Another analogy for people that are more into cloud and DevOps is imagine if you have something similar to Amazon VPC, but for every connected device in the whole planet. That's what we do. And under the hood, ZeroTier handles directly connecting everything to everything else, negotiating tunnels on demand. It basically builds a mesh, distributing keys, authenticating the nodes, all that other stuff. And things like mobility don't matter. If things move around, and if I close my laptop and go to Starbucks, I'm still on the company LAN. I'm on the company LAN right now. Your Mac is the same, your address is the same, everything else is the same. So yeah, like I said, everything's in the cloud. You've got your cloud, you got your on-prem data center, which never looks like that, and you've got your and you've got your mobile devices, your laptop, your coffee maker, if it's big enough, that kind of thing. So the basic idea of what ZeroTier is a lot of people think it's a VPN. It really isn't. We think of it as either I like the term network hypervisor. That's what we actually call the core of the product. SDN that works everywhere is another way of thinking of it. It's not a VPN, but you can use it as one because our sort of crazy thesis is VPN, SD-WAN, multi-cloud, SDN and a data, all these other things. They're special cases of network virtualization or SDN. So the way ZeroTier is built is it actually combines ideas from two different sort of subcultures or subgroups of the networking world. The first of them is so where this actually came from is I was part of a group of people called Redecentralize, working on decentralized internet, mesh network type stuff. So this is the peer-to-peer networking people, the meshnet people, overlaps a bit with the cryptocurrency people, at least technically. And the idea there is to be able to just to not have all of your data take the scenic route, but to make, as the photo says, every network endpoint is equal, man. That's what we want, right? So that in ZeroTier came together with something else, and it became what I call VL1. So in OSI terminology, layer 1 is the transport layer, the wires, the radio, whatever. VL1 is a cryptographically addressed, secure peer-to-peer network that gives you what we like to think of as kind of a wire closet in the middle of the earth. It takes care of getting packets from point A to point B and trying to find the most direct route for doing that. It takes care of failover. It also has a whole cryptographic infrastructure that the later layer can build on top of that gives it what it needs to be able to do authentication and certificates and stuff. You can use the keys from VL1 to know who you're talking to. It also has some advanced SD-WAN type features. We actually have a multipath engine that allows you to do load balancing across multiple WAN links, or you can do active passive failover. So you could have like, if you have ZeroTier in a box, like a router or something like that, you could have like an LTE modem as failover, and then if the main WAN link dies, it fails over to the secondary. All that, most of our product just works. That actually has to be configured, but it's not that hard. The configuration interface for it is modeled after what the Linux Bond driver configuration looks like. And then on top of VL1, we built VL2, Virtual Layer 2, which that is an Ethernet emulation layer. It isn't VXLAN, but what it does is kind of functionally similar to VXLAN. It runs on top of VL1, which that's cool because VL1 gives it the abstraction of every node on Earth is plugged into a wire closet. So on top of that abstraction, then VL2 doesn't have to care about how to route anything. It just gives you the abstraction of an emulated L2 segment with a whole bunch of fancy features. So this is your virtual smart switch. So with VL2, you can create VLANs, basically. They're not the same as, VLANs on a switch, but the concept is the same. You can do filtering, you can do traffic duplication to a security observer, you can do transparent relaying through nodes, you can do what's called microsegmentation, where you set different flow rules based on things that are tagged differently, kind of an ACL style system. You can also take a VL2 network and you can either run ZeroTier on a box and bridge it to a physical network or a route to a physical network, or you can do layer 2 bridging. You can actually bridge it to a physical network. That's really fun if you have that in your house, because then you can play stuff on your smart TVs when you're on the road and prank your family. So here's some of the features. And I wanted to make the point that a lot of these features just sort of emerge intrinsically from what ZeroTier is. They're just cases of things you can do with it. The product itself, I actually like to keep clean and not like a feature Christmas tree. When you virtualize it layer 2, you can do pretty much anything you can do over a switch. So you get a lot of these things for free, but not all of them. So, one of the core ones is that this is really easy to deploy. You basically can just install it on almost anything with a chip in it, and you can join networks. That's it. At least for the basic use case. When we get to our demo, they always have the problem of being too short because you don't have to do very much. On most networks, it just works. Sometimes you have to configure the firewall a little bit if your environment is like really locked down. And an it'll use IPv4, IPv6, it'll use any physical transport you have. It is possible to deploy the whole ZeroTier infrastructure in a private air-gapped network. That takes more work, but it can be done. One of the things we'd like to do in the future is make that easier, because a lot of enterprise customers actually do want that. You can automate it. You can push it out to machines using configuration managers. And what this means is you don't have to buy any hardware. I don't know if I was clear before, but you don't have to run ZeroTier on a box. You can run it on your laptop, phone, but you can choose. You could have a gateway that just is a gateway for your whole place, or you could run it on all the devices or any mix of that. And incremental adoption. You don't have to rip and replace anything. It'll use all your existing pipes. And so people can adopt it at the pace that they want to. And a lot of people will start using it initially for a certain task, and then it'll kind of expand the use as they figure out other things you can do with it. Security. Everything's encrypted everywhere, which I really believe is the way things have to be these days, because the internet is a dark forest. That's one of my sayings. The key distribution and everything is automatic. I already mentioned that. And then if you want to, and this is a distinction from, so there's a lot of things coming out right now that are zero trust. I like to say we were zero trust before it was cool, but a lot of these zero trust things, the idea is actually it's not zero trust. You're putting 100% of your trust in a cloud provider that actually owns everything. And what you can do with ZeroTier is, if you want, you can self-host the network controllers that are the CA for your VL2 network. It's not that hard to do. And if you really want to go further, you can actually do federated instances of routes or air-gapped systems. So you can own your security boundary and your keys. And what's cool too is when you do that, you don't lose compatibility with the rest of the network. So if you still want that ease of use, if you can just send someone the ID of a zero-tier network and they can just join it, you don't lose that. You can control your security boundary without losing any usability. And they don't have to do any special configuration to make that happen either. It's a federated, decentralized mesh, you know, back to the smoking guy. Rules and microsegmentation. VL2 has a rules engine. You can set rules about what kind of traffic is allowed on your network. A lot of people sometimes freak out about, oh, you're emulating layer 2, you can do all kinds of attacks. You can lock that down. You can also assign little buckets of rules or tags to individual nodes or groups of nodes. So you can do ACL style. You can either do just a global rule set or you can do ACL style stuff or mix and match. Right now, the rules engine is pretty low level. You have to know TCP/IP to use it. One of the things on our roadmap is to build some higher level abstractions with pretty UI and stuff, or at least a higher level language on top of that. So it makes it easier to speak in terms of intent. Right now, you have to just tell it what to do, but intent is where we want to go with that. It also has some pretty powerful security monitoring features. If you have a smart switch in a building, a lot of times they have something called a tap port, where you can plug into it and you can plug it into a device that sniffs all the traffic on the LAN, and you can do security monitoring and watch, like, for example, all the TCP connections in your network. You can do that with this, and you can also be selective about it because this is a distributed network. You might not want to backhaul all traffic on your global virtual network to like one node. You could if you wanted to. And you could do it either by sending copies of the traffic or actually routing the traffic. It's up to you. You can also be selective. And one of the really cool tricks that I like to do with this is send me up to the first 128 bytes of every TCP SYN, RST, and FIN packet to this node. Now this node can sit there and just watch in real time the opening and closing of every TCP connection on the network. And it doesn't have to man in the middle all the traffic, so you don't lose any efficiency. The rules are enforced on both sending and receiving sides. So if you wanted to defeat the rules engine, you'd have to break into both sides. And then usually changes take effect in under a minute if you edit the rule set. So you could jump in there and even make a change to look at something. More layer 2 features. This is a little design detail that's kind of cool. Layer 2 is free. It doesn't add any packet overhead. It's because the Ethernet headers can be computed. I'm not going to go into detail. I don't have time. Bridging, mentioned that. We do handle IPv4 ARP in a special way because ARP was definitely not designed for a WAN. But the way that's done is transparent to the OS or the device or whatever. So it looks on the virtual wire like it's just doing ARP. And then you can also do crazy things. You can run non-IP protocols. This gets interesting not just for people that want to play ancient games, but also in the industrial IoT space. You have things that speak weird protocols like CAN bus over Ethernet or stuff like this. That will work. It'll especially work if you bridge it. You can even do BGP. We have people that have run a virtual carrier hotel or a virtual BGP meeting and used it that way. And then use because they like BGP and they use its features to do, failover type configurations.
Yeah, so that was one of the things that was most interesting to me about ZeroTier, and I've been using it for a long time. I think maybe 4 or 5, 6 years, something like that, since you guys first got started. And to touch back on what you were talking about especially non-IP protocols as an overlay, I think one of the things that was interesting to me, and I'm curious where you guys have seen the use cases, is something like ISIS. ISIS doesn't run at layer 3. It's used in carriers all over the world. As a routing protocol, it needs an L2 adjacency to do it. How are you seeing people leverage that? Because the other things you mentioned about the manufacturing networks and and non-IP and even non-standard Ethernet, we see manufacturing companies and all kinds of companies use this. How big has that been in differentiating ZeroTier?
It is so what we find is that's really interesting to people in the industrial space. And we've also had some government interest. these kinds of things. I've never heard of that specific protocol, but I'd give you a 95% chance it'll work. If it speaks Ethernet, it'll generally work. The thing that I've heard the most about is remote access to legacy equipment. So for example, having something in AWS talk to some old machine that speaks some weird Ethernet protocol in a factory, we have that. But yeah, try it. It'll probably work.
Right. Yeah. And I don't want to jump ahead of your presentation, but are you going to get into using it as a public overlay and not just a private overlay with no authentication?
You can do that. Well, I don't know what do you mean by public overlay?
Well, like so sometimes the zero-tier networks where you don't have to authenticate, you can set it as public and other people can join. That was one of the most interesting things to me, because we have a network we use ZeroTier for IPv6 called ZTVI. With Nick Baraglio, who's also a field day delegate. We use as an IPv6 research lab for BGP routing, global internet routing, because it's, people can join, it's public. And I think that's another thing that was interesting to me that sets it apart is it doesn't just have to be a private, overlay. It could be a public overlay as well.
No, you can be as secure or lack thereof as you want. There is actually a setting on networks called public where it just turns off node access control and anybody can join it. It's kind of like a public IRC channel or something. And a lot of gamers use them too. They're used for a lot of private use cases. Oh, here's a big LAN party. You can just join it. But yeah, I'm going to go on because of time. But those are that's an interesting use case that I actually hadn't heard of that. That's cool. I do know that we have some MeshNet people using BGP on it in Germany somewhere. That's for like some Berlin Wi-Fi mesh. But yeah. So layer 3 features, a lot of so we've actually been around for a while. We were incubating for the first couple of years. Our initial, the angel investors that helped found us, I was kind of upfront with them about like, we're ahead of our time. We're going to have to wait. There's some things popping up now that do this just at layer 3 by using things like either their own protocols or WireGuard or whatever. A lot of them have a lot of restrictions on what addressing schemes you can use and stuff. We don't. When you join a network, it shows up and acts just like an Ethernet port. You can assign any kind of address or combination that you want to that port, and it'll just work. So there's no restrictions. Even link local addresses work. We also have a special addressing mode in IPv6 called 6-plane. All you have to do is turn it on, and every node on your network will get a /80 that it can route within. Now, the way that's actually implemented is when that's on, the local ZeroTier node will emulate IPv6 NDP. So what you get is every node on the network gets a routable /80 and no routing updates have to be sent over the network. It just works. The magic there is that IPv6 addresses are big enough that you can embed the ZeroTier address of nodes into the prefix of the address, and then it can emulate IPv6 NDP locally. So this is cool for giving you like infinitely large networks for like VM hosts and containers where every node can unilaterally assign up to 2 to the 48 addresses locally without having to tell anybody, and they all just work.
And so that was the reason you did a 80 versus a 64 was
you got to cram the address info in there.
ZeroTier bits on the far left portion. Okay.
Yeah, I'm not aware of any OS that doesn't work on, but and then you can do, this is a VL1 feature. You can do physical network bonding and failover. This gives you some SD-WAN features. Now, we do not have the long feature list of some of the dedicated SD-WAN boxes, although some of that stuff is actually on our roadmap. Things like traffic, like more adjustable prioritization and stuff like that. But it does give you what probably 90% of users need, which is to be able to either gang together WAN connections or do fast failover. And then we also have something called the ZeroTier SDK. So what this does is it takes the network hypervisor and it couples it with a small embedded TCP/IP stack, and you can link that into an app as a library. So that allows, for example, a mobile app to join a network without putting a VPN port on the phone. So we have one user that used this to make a mobile app that can talk directly to cameras on a ZeroTier network without having to have any special permissions on the phone. You just launch the app, and the app is a device, and it pops up and it has its own little embedded stack and it talks to things. You can also run it, if a lot of IoT devices just run Linux or similar to that, you can just run it on there normally, you know, alongside everything else. You know, we have cameras, NAS devices, drones, all kinds of things. The agent only uses around 32 megs of RAM unless you're doing anything crazy. And then some other highlights. I mentioned that Zero Trust before, it was cool. I am kind of happy that we finally have a buzzword we can reference, because I've been howling at the moon about this stuff since like 2015. And a lot of people were like, what is it? Okay, we can say Zero Trust now, and it overlaps a lot on the Venn diagram. It also, VL1 has a bunch of smart stuff for discovering local links. So if you have two nodes on the same LAN, it'll figure that out and the traffic won't leave the building. I like to say that the idea of, you know, I transfer a file to you, we're sitting next to each other, and the file goes like 2,000 miles. As an engineer, I just find that offensively stupid. Like, it should just go locally. So that's what it'll do. Also, if you've got private WAN links that have private addresses, like you got MPLS infrastructure or something, it'll just discover that and use it. So that'll become one of the routes that it uses. It'll also, if your router has UPnP or NatPnP, it will use that to improve its likelihood of doing a direct link. And then last but not least, the routes will actually relay traffic if you can't make a peer-to-peer link. So if you're somewhere behind some crummy or lockdown router, you can't make peer-to-peer links, it'll still work, it'll just be slower. All right, and then integrations, so stuff this runs on. We actually have a mug that has that on it. That was one of our first pieces of swag. Connect all the things, because our mission statement is to directly connect the world's devices. So OSs and we've gone porting crazy. This runs on almost anything with a chip in it that's 32-bit that has enough RAM. Actually, there's some architectures not listed. There's some weird Chinese architecture somebody ported it to. Forget what it's called. And Rush, what is it? 32 yet? I don't. Actually, I don't know if that has enough RAM, but I'm sure people have tried. We actually have a vendor-supported integration now. Microtik out of Latvia shipped ZeroTier and Router OS. They worked with us to do the integration, and we have ongoing discussions with them because we don't want to make hardware, so we might do some co-marketing with them. We also have some integrations that we've done that we support. Ubiquiti, Western Digital, Synology, NAS is pretty popular. And then there's a bunch of community ones. That's just a couple. OpenWRT, OpenSense, Teltonica, various other things. We also are getting more and more into the DevOps world. We don't quite have a solid Kubernetes story yet. I mean, you can use it on Kubernetes, but you got to figure it out yourself. But we're working on that. We have, Docker containers, Terraform. Terraform is cool. If you search YouTube for the IBM developer demo with ZeroTier, you'll find a demo of somebody setting up a multi-cloud infrastructure with Terraform in like, I don't know, a minute or something. And then there's some community supported ones. People have made modules for CM systems and stuff like this. Common use cases we see in industry. I'm running out of time, so I'm gonna go fast. VPN, SD-WAN, out-of-band device management. So, secure ways to access your on-prem devices or SCADA systems or whatever that's more secure than just hanging them out on a redirected port on the internet so they show up in whatever that search engine is. I forget it now. Shodan, yes, Shodan. You don't want to be in Shodan, so this won't show up in there. MSP management. We have a lot of MSP customers that'll install ZeroTier on their customers' stuff. And then that way, when their customer calls them with a problem, they can just come right into the system and fix stuff. Some of these are simple use cases that literally take 5 minutes, 10 minutes to set up. Some of them require a little more configuration work. Industrial IoT. Intrusion detection, that's actually referring to a number of things. One of them is you can use this to install on stuff and have it stream logs to a Snort instance or something. You can also use the rules engine to do taps and to do security monitoring. And of course, lots of people use this for LAN gaming. Lots of home lab people use this. multi-cloud and hybrid cloud. This one's cool. Did you know, like, I heard a statistic from a salesperson in a big company that up to 40% of large enterprises now have ended up with infrastructure in more than one cloud. In this case, you have a VPC-like managed backplane network across anything you want, on-prem, off-prem, in your company restroom. And you can just transparently move resources around. They can retain the same addresses. If you retain, your address is defined by your secret key. So if you copy the secret key, the device pops up and it's got the same address. And then network as code. You can actually do this now. And that's the search YouTube for that Terraform demo. It's cool.
We use it huge for out-of-band as well. It's out-of-band networking, especially in ISPs. There was an ISP we worked on the Pacific Northwest. We moved 5 entire towns on the internet served by an internet backbone over there using a MikroTik router and ZeroTier as out-of-band over LTE. So we moved part of an entire state's internet backbone over using that as our out-of-band so that we weren't, dealing with the forwarding plane. I think I see a lot of people using it for out-of-band. I think there's a huge use case there as well.
Yeah. And then a lot of people use this. We've had a growth that, I'm a math nerd. So if you put our growth, a lot of our growth curves on a logarithmic y-axis, you can hold a ruler up to it. And it's like this nice, pretty solid exponential that is a straight lines on a log plot excite me because I have a science background. I think E is a cooler number than pi. Anyway, there are over 650,000 active networks in 2021. These are just all cool statistics. 175,000 network admins using it. Also, this is not on here. ZeroTier nodes exist everywhere on the internet that has internet access. We did a geo-IP plot of from a network scan once, and there's nodes on little Pacific islands and in sub-Saharan Africa and just everywhere in the world, which is cool.
What's the scalability like in terms of number of nodes supported on a single network?
So theoretically, you could have up to 2 to the power of 40. The thing that usually gets you on scalability is multicast and broadcast. If you use one of those emulated modes like 6-plane, where it emulates the NDP and use IPv6, then you can have a multicast and broadcast free network, which can go up to 2 to the power of 40 nodes on a network.
So did I get that right? I have to install an agent on the devices I want to connect.
You can install the agent. The agent has to be somewhere. So it's either on the device that's connecting, or it's on a router or a firewall or some other device that's providing access to, for example, your local LAN. So we have people that use this in an SD-WAN. Another buzzword for that is layer 2 stretch use case, where they just have it running on router boxes at multiple locations, and they have one LAN by just bridging the locations together. Stuff like that.
And there's a central management, I assume?
Yes.
Is it cloud-based in your cloud?
So one of our products that we make money on is we have a SaaS. We will host your network controller for you in a high availability environment and give you a pretty dashboard and an SDK for that, or SDK and API for that, for central management. But you can also do local management if you want to run your own network controller. And another thing on our roadmap is to offer what we call ZeroTier Central, which is that cloud management dashboard and API as a product that you could fire up in your own Kubernetes cluster. We're not quite there yet. It's more a polish kind of issue, but we have to make it so people other than us can deploy it. But yes, that's one of our enterprise products on the roadmap.